we're talking about adopting Erlang and adapting Rebar. This is a bit of a odd talk, I guess, but we wanted to cover something a bit interesting that we've seen in writing the book site, Adopting Erlang, and how that led to changes in how we, maintain Rebar and do that kind of stuff. So really, the first thing is, I don't know who has seen or read Adopting Erlang. And so the first thing I want to do is then talk a bit about what it is and why we started to create that one, right? The big thing that we've seen is that Tristan and I worked at a few jobs together, a few jobs not together. And the kind of common experience we had in joining multiple places and doing Erlang in these was that, everyone has this kind of knowledge, understands the mechanisms that are behind the language, all that kind of stuff, and there are books to help with that. But there's the gap between, I'm programming alone, I'm making my first project or something like that, and I'm starting to program in a team with someone and with a bunch of other people, and we have this long-term project to run, and there are all kinds of questions to do with that one that are both technical and social, and there are not necessarily a lot of good resources for that. And so a lot of the things that we would see when we came into different companies was a bunch of things that we felt needed cleaning up, could be done differently, had ideas with improvements. And after running that in multiple places, multiple times, it became more and more obvious that, there's a kind of recipe that we can apply to that one. We had seen the Adopting Elixir book being a kind of thing like that. And we kind of decided like we should put this in easier to consult format rather than having to, do that kind of work more or less for ourselves each time. And so we wanted to do that with the best practices and put them in an easy place to see. So it's adoptingerlang.org. And so far we've divided it in 3 sections: the development, production, and teams. In development, really, we took the approach of explaining a multi-platform, multi-version setup because all the books and all the sites kind of avoid doing it with one platform or something like that. We wanted to clearly mention like how editors could be set up and stuff like that. Top-down explanation of the VM-wide expectations and the depths and the kind of structure. When we join new companies and explain stuff, like it was easy to start with the high-level explanations of OTP and everything like that, but there is something about the mode of development of shipping a release, building it, how that stuff gets deployed, and it kind of fits together from beginning to end. And so we tried a different approach. There are more chapters that we want to publish in this one that are not there, like getting your continuous integration going, testing practices that are useful in the business, docs and configuration play that kind of same role. In production, Tristan's written these chapters that you've possibly seen because they've been super useful on releases, Docker and Kubernetes, and how to make Erlang and VM fit like that and making it work well. We're still planning on writing about setting up observability, operations, and all these tools to help. And the team section right now has nothing published, but we wanted to give our views on how to build a team to run and maintain these services, how to hire for that team, how to actually do polyglot programming right, because most places that adopt Erlang don't do it for their first product. They have teams of developers that work with something different. And there is a way of doing polyglot programming that we feel could be more useful and helpful than the current approach, which is usually just throwing bodies at the problem. And we plan on doing something about defending Erlang at work because we've had a lot of discussion in a lot of places, and there's always a lot of questioning about doing that. Tristan.
Thanks, Fred. Yeah, so as Fred mentioned, we've been maintaining a lot of tooling and been running a lot of Erlang production deployments over the years, and started writing this knowledge down in Adopting Erlang. And during that time, it led us to really come to terms with a number of issues that have grown over the years with the tooling. And I'll start with releases and Relx. Go over those. Thank you. So releases for a modern environment, and this is where tooling and production really overlapped well. The times have changed. The books written and lots of other resources online for Erlang and releases have started to be dated and don't cover what many companies are now running like Kubernetes or just Docker or running releases in systemd. And this leads to some confusion and bad practices. And uh, we wanted to cover that really well and give our experience and what we've learned. Some simple things as configuration these days, or at least since people started moving to Heroku, was environment variables for all configuration. And that led to some changes with adding .source files for sysconfig and VM args. And we cover things like that for best practices of configuring your release at runtime. And even simple things like what command you should run when starting your release has long been a pain point and an issue for the community and a confusing part of Relx and releases in general. So to start with, when you're maybe using Docker, it's not even a question of running the release that is painful, but just building your Docker image. So in Adopting Erlang, we cover efficient building of those Docker images. You want to cache your deps based on a rebar lock file so that when it changes, it will fetch the new deps and rebuild them, but you don't want to have to do that every time. You only want to do it if something has changed. And there's some neat new features in Docker, Docker's new build kit backend, which allows for caching even local stuff like hex packages. So this way, if you do have to rebuild your dependencies because the rebar lock file changed, it will still have those hex packages cached and not have to go to the internet to fetch them, which before usually you would have to do that, even though you were just building the exact same versions of these libraries. Then it comes to runtime concerns, and Beam until OTP 23, something we'll get into more, was C group unaware, and C groups are what Docker uses for creating the Linux containers. And so it would not start a scheduler per CPU that you've given it through Docker. It would start it for every CPU on the machine. So if you deploy you deploy your Docker image to a big node in Google Cloud or AWS that has 24 processors, and you want to give all your Docker images different limitations and maybe just give it one CPU, it's going to start 24 schedulers. And it's going to busy wait, which is what it does when a scheduler, an Erlang one, runs out of work and needs to go to sleep. But instead of going to sleep, it does a tight loop and burns up your CPU. And that is even more detrimental in Kubernetes, which I'll discuss in the next slide. But also the Docker image is supposed to be one process, and that process is the init process. Init processes have to handle any process that goes down or stops even for a normal reason. They have to be reaped, or they take up memory for forever, and nothing can get rid of them except that parent process that is PID1. And until OTP 23, this was also an issue. And now the Erlang VM can properly reap child processes that are zombies. But if you're on anything earlier than that, the book covers ways in which you can deal with this besides upgrading to OTP 23. Thank you. So with Kubernetes, you have all the same problems you do with running Docker images of the 423 being unaware of the CPU limitations that you were given, and that busy wait, which gets even worse if you're using, well, the defaults when most people run Kubernetes, which is the Linux scheduler with CFS, which is supposed to be a fair scheduler. It will start throttling you if your CPU usage hits the limits. And because of that busy wait, it will hit that limit and you will be throttled. And it will make it look like all those people that say Erlang isn't meant to run in these environments like Kubernetes. It'll make them look right, because you'll get terrible performance because the kernel will start throttling you right away, and you won't be awake to handle requests. So we cover both how to configure around that, the busy wait, and how in Kubernetes you can get from your pod the number of schedulers that you should start based on the CPU limits that you've set. And for deployments, since you're mostly going to be doing rolling releases, rolling updates in Kubernetes, it's important to cover how those work, and the fact that since OTP 19, you have signal handlers in the VM. So if you get a SIG term, which is what Kubernetes will send to your container when it wants it to shut down, since 19, it will properly do an init stop and stop your applications and release in a graceful manner. Before that, you would have to do some extra handling to make sure that Kubernetes stopped it without just killing it in the middle of it doing something. Another section Kubernetes will be covering soon, it's not published yet, is distribution, covering the EPMD process. So you have this port mapper daemon that doesn't really provide functionality in Kubernetes because you're contained only a single VM within this container, and you know what ports you're exposing, what ports other nodes are allowed to connect to. So you don't need this port mapping daemon, but you actually have to run it even to do stuff like running remote procedure calls, connecting a remote console. Even if you're on that, running in that container with a shell yourself, that EPMD process still needs to be running just to do that. And so with OTP 23 and Relx changes, it's become much simpler to run your release on a static port and connect to it with a remote console without all the hassle of EPMD and ports being picked for you. So through this process of writing this, and just over the years of using and showing other people how to use, and people coming with concerns, we came up with a number of issues with the release tools, which is Relx. There's just simple stuff like duplicate code that Rebar 3 and Relx have a shared history that I'll cover next, that led to lots of code being duplicated between the two, and that just slows everything down because it does things twice. It's hard to use the scripts that it generates without EPMD, and we wanted to fix that up. Mentioned earlier, confusing start scripts that just were not intuitive. And so we felt after writing this, it was finally time to break backwards compatibility and have a Relx major release 4.0. And this was done as part of the Build and Packaging Working Group of the Erlang Ecosystem Foundation. So, as I mentioned, Relx and Rebar 3 have a common history. Relx actually predates Rebar 3. It was originally named Rel Cool, and started by Eric Merritt. But we decided that was too similar to Rel Tool and would be much too confusing. So the name was changed to Relx. I really liked Rel Cool myself. So because it was built at that time to be used with Rebar 2 as a standalone eScript, it had to do a lot of your normal CLI startup things like parsing arguments and running different commands based on what arguments are passed in. And this actually became the starting point of Rebar 3. When we started Rebar 3, we took parts of how Relx's provider system works for running tasks and having dependencies of tasks and parsing commands. But that was that led to this kind of coupling of them both working very similar, doing the same work. Next slide. So Relx changes that came from this were basically a near rewrite of Relx to slim it down from being this standalone eScript that did much the same work that Rebar 3 was now doing, like figuring out what OTP applications you had in your project. That was being done twice because Relx had to figure it out on its own after Rebar 3 calls it, and Rebar 3 had already done that work itself. A lot of functionality was removed, which some of it is simply duplicate functionality. Some of it was not necessarily duplicate, but not needed anymore, like Relx's ability to have version constraints. It was a bit more complex version constraints than what Rebar 3 can do, so it's not an exact duplicate, but it was removed because when you're calling from Rebar 3, you've already restricted and picked what applications you'll be using in the release, so there was no need to parse those again and check. We simplified configuration. There's defaults that over the years we realized we're always including in every Relx configuration, and especially in the book, seeing how often the boilerplate is there. And so we wanted to get rid of that and have a much cleaner Relx configuration that gets right to the point and gives you the best experience without knowing all these different configuration items to do if you want to get a proper release for your deployment. And this included adding modes. Modes are a new thing that before we had dev mode. You might be familiar with that, which symlinks instead of copying the applications into the release. But we've added two more, minimum and prod. And prod will include ERTs in the release, and it will then strip the debug information. So you have a smaller release because the beam files are smaller, and will exclude source. Before this mode option was added, you had to add each one of those individually on its own to get this functionality. And the extended start script, which everybody uses, is by default included. And before, you had to add that yourself into the configuration, or it would give you a start script that just ran Erl and was not very useful in production environments. And the minimal mode is the same as prod, but it will exclude the ERTs, the Erlang runtime. And some other nice things that were changed was support for xref is added. And xref it uses xref without the E that you might have used before with Rebar 2. Nix xref will check and make sure that the applications in your release are the ones, you have all the ones that you need. This has been a common problem over the years where someone forgets to put an application in their .app file, and that is what tells Relx it's a runtime dependency and will include it in the release, but they're calling it from their code. And this xref check will make sure that that doesn't happen. It will warn you, or error, that you're calling these modules that don't exist. Sadly, it is not yet a default in Relx. It has to be turned on because it doesn't work if you're using Rebar 3 as an E script because of issues I won't get into here, and some path problems that exist. But you can easily enable it on in the Relx configuration. Similar for source tests, this is always on by default if you're including source in the release you're building. So it's nice for that initial step of building a release before you're building the production release. And it simply checks that the Beam files and the source files are not out of date. So if you have changes to an URL file in a dependency and that's not, and you have a change in that URL file and the Beam file is out of date, Relx will tell you and warn an error so you can check what's going on, because to make sure that dependency is actually compiled properly and you've been testing against the right code. So next we have the start script changes. The Relx start script, or extended start script, that's now included by default. It's gone through a lot of improvements over the years, but for just as long has needed a number of complete revampings and changes. A simple one that I've harped on twice now is the fact that the command to use to start your release isn't even clear. Most people coming to this fresh will see the command start and assume that's what we expect people to use to start their release, but it's not. It's what we encourage against, which is very confusing, that start is the one that the developers expect you not to use. So that has finally been renamed to daemon, and which better gives a sense of what it does as well, because it runs the release through this run URL command from Erlang that puts it into a daemon and daemon mode in the background and writes logs all to a file, and just a lot of stuff that doesn't need to be happening if you're running in Docker or systemd, where you want logs to go to standard out where they can be collected and rotated through some other system instead of Erlang dealing with it. And you don't want to have a PID file in systemd that has to be used to start and stop and kill the release. So you run it in the foreground, and systemd can handle all of those tasks. Another pain point in the Relx start script has been RPCs. For some reason, this is a long time from Rebar 2 issue of having RPC terms and RPC. So there's two commands for running RPCs, and nobody ever knows which one to use or how to pass arguments to them, even if they've picked one. So we've slimmed that down. There's now just one command, RPC. And for the arguments to the function you want to call, it simply takes a string which contains a list and ending in a period. And each element in that list is an argument to the function you're calling. So the length of the list is the arity of the function that you're calling. Additionally, with these new improved start scripts, we have OTP 23 changes incorporated. There's changes for the selecting a port for distribution and for not listening on a port when you start a remote shell. Until OTP 23 and this start script changes, when you pulled up a remote console to your running release, it also binded to a port, listening for other nodes to connect to it. And this is not something that was ever made use out of by people. So it's nice that you can now say, don't listen on a port, and that way you can set a single port for everything to use on the actual release node that's running and not worry about conflicts when you're trying to simply open up a remote console. A big thanks has to go out to Regan Heath, who provided us with awesome PowerShell scripts that are now in Relx. So if you're using PowerShell or you're using Windows, you have a much better extended start script for running.
Specifically to add on Windows, it used to be a batch script that couldn't do half the features required to do the same thing as the Linux one. And in doing these updates, the Windows scripts are now able to do all the same tasks that the Linux ones are able to do.
Yep. And then lastly is finally got around to, with this time, to have better shell tests for the scripts. Before, it was using common test and shelling out, and those would constantly end up timing out in CI. But now they're run directly with this tool called Shell Test Runner, and PowerShell scripts are tested as well. It used to be that the Windows scripts weren't even tested in CI because that was too much of a pain. But now on GitHub Actions with Windows support and with the new PowerShell scripts, tests were added for that. So hopefully no more breaking the Windows scripts when we make changes.
All right. Another thing that we found while writing the early chapters were issues with the compiler and rebar theory itself and how things were working. So Tristan hinted at this a little bit, but there is a bad distinction between the build time and runtime dependencies, right? The build time dependencies are those that you specify in the deps tuple in the rebar config file and those that are being locked. And the runtime dependencies are those that you mention in the .app.source file. And we found out that there was a common problem that a lot of people were having, where if you had many top-level applications that relied on each other for, things like behaviors, parse transforms, or headers, sometimes they would not detect each other. And the trick was that if you put the application as a runtime dependency, then it started compiling fine. And that was kind of very common workaround that we felt was okay, but in writing it out, it felt entirely ridiculous. We also knew of some problems about, the analysis is done for each OTP app. So if your OTP application relies on a behavior that's in a different application, it doesn't work super well. And that's kind of a thing that you inherit, or that we inherited when we took over Rebar 2, because it did per app compilation at that point. I always expected most of the things to be dependencies. We had the same kind of expectation, and we baked that back in the tool again. And so the build order between the top level applications was not even being considered. Like, we called to sort them, and the only thing it sorted them by was the application name. So the app name A was always compiled before B, and that's how it worked up until the very latest releases. On larger projects, we've heard that things were extremely slow. We've had for a long time problem of not having a very large project to try them with. We also knew that we could not do a lot with the code, from the simple reason that a lot of it was inherited from Rebar 2.x. We hadn't written it. Some of it we had refactored, but we still had that core of all the analysis in the application, which is something that we brought wholesale and never properly took ownership of. And so we had big changes. So the structure that we had in Rebar 3 that you use every day is the one on the left. All the dependencies are built once, and this is fine because if you need to change dependencies, they are changed in the log file, that triggers a rebuild, but otherwise they are never rebuilt. And the compiling steps were per application. So this big orange box on the left is one application, and we run all the hooks for them. Then a little directed graph of all the files and their dependencies, and we store that on disk. And then we compile them by reading on that and checking like the beam files on disk with the stuff that's in the graph, and then we know what changed. And then we did the same phase a second time over for all the extras. And the extras here are like your test files and stuff like that. And so the test files had their own small graph where they ran a kind of analysis. And then once that was done, you had all the beam files ready. We could run the other hooks, build the .app file, and then move on to the other application and do them one after the other. And initially, we felt that this kind of made sense because we could build all the applications in parallel. But that never really took place because if you rely on an app that has a behavior and one on parse transforms, they kind of all start exploding. And so the Earl first file parameter is not really great to work across applications. So we restructured all of that to what is on the right. And we decided that all the top level applications should be done at once in phases. So all the hooks are run for all the applications. And then we start a big ass analysis that goes into all of these top level applications, scans all of their files, put them into one big graph instead of having distinct ones. And then we can build them all and we reuse the same graph for the extras and all of that. And we keep working on that same view of the world. And then we do everything else for all after each other. And that was kind of risky to do because we didn't know like how tight the ordering within an applications could be to other applications, but in practice it seems to work pretty well. And having a bigger graph a good decision because we changed a lot in terms of correctness. So the runtime and build time distinction is no longer necessary. If something is in your deps file, it's going to be visible. If your apps are on the disk, it's going to be visible. And the runtime and build time are completely distinct concepts. One of the other problems that we had and was reported is that all the analysis of what is happening within a file, we had an internal parser that looked at all the abstract code formats to figure out which files were being included, which options were being put, what is being called in terms of behaviors and parse transforms and stuff like that. But it never understood the macros that you could use. So if you had something like, if def test in somewhere to include a test header, we never really cared about that. We looked them all and sometimes it tried to include things that didn't exist. Sometimes it went kind of wrong. So we switched to ep, which is provided in OTP. We hooked it with the configuration that is in the rebar.config file, and now it only does the recompiling and rebuilding that's required for what is on the system right now based on the profile and the options that you would be having. Having the one big graph fixed across app behavior, path transform, and header dependency so that if you switch a behavior in app B and app A relies on it, app A is getting recompiled along with it, which before then wouldn't happen. And you need to like clear the beam files in all the projects that included something to work. And when you relied on something like one header files for everything in many projects, it was kind of garbage as a workflow. We also properly pick up all of these things. And between the tests as well, because it's another thing that sometimes fails is that if your headers were on test somewhere else, then test modules wouldn't be recompiled, and now that's being handled. That means that the Earl first files options should no longer be needed for anything because it's all in the graph. You no longer need to specify that. It requires a bit more parsing to do. We have other changes that had to do in terms
wrap
of
up
the impact.
shortly.
Other things that we, yep. This is like my second to last slide. So we track the build artifacts in the digraph, which means we no longer need to read on disk and go fetch the options from there. We have that all in memory, and we're future-proofing for compilers or the OTP team that would like to add more artifacts. We haven't done them yet. We've done some small experimenting, but nothing big. It is slower on initial builds because we build bigger graphs and do more analysis, and it has a bit more memory usage. But when you do a partial build, like you just change one file and you try to rebuild that one, in real world projects like Eternity stuff and even WhatsApp's applications, it's twice faster than it was on the previous version. And in some terrible cases where we make synthetic benchmarks with applications that go in all the worst cases, we are up to 20 times faster while also being more correct in what we do. And this is done without breaking backwards compatibility. We expand the existing plugin interface for compilers that we use internally. And so people who build other languages on Rebar 3 for the Beam should be able to do that. And on that one, I want to thank Max Fedorov from WhatsApp because he helped us a whole lot, especially with the bigger builds. We complained a whole lot to a lot of people that we never had the big projects to try that stuff on. And he spent a lot of time with us running the benchmarks, trying our branches and finding optimizations. that helped us really like double the build time. Make the build time twice faster on their million lines of code applications in Erlang. And so to close up, this is going to be all in Rebar 3.14, the Pi edition. And so we are cutting it right after this talk for the second release candidates. We're also publishing 2 new Adopting Erlang chapters. So those are going to be about team building and the polyglot chapter that I hinted at the beginning of the presentation. And we didn't have the time to cut the final 3.14 release today, but we're planning to have a new doc site that replaces the rebar3.org that's on readme.io and requires a lot of JavaScript. And we want to rewrite the content so it no longer assumes that you're migrating off Rebar 2, because the ecosystem is changed and not a lot of people are doing that migration anymore. And so, yeah, that would be it. And my closing statement would be that if you're writing documentation, it helps you take the new perspective that is extremely useful to find all kinds of problems you have with your systems and the things that you write. All right.
Excellent. Thank you so much. All your contributions are very, very appreciated by the community, and this is excellent talk. Thank you very much. You got a lot of questions, so please address them on the event page. And this was it. Thanks you.